Well, basically, by stimulating the muscle, essentially what we're doing in a way is a chemical version of electrical stimulation. Some of the same things happen. The muscle goes into rigor faster, but because we're adding sugar, we're preventing dark cutting, and because we can modify the pH depending on the issue, we don't see the beef version of PSE.
Hello, me folks. Welcome back to the MeatsPad podcast. On our RMC series, we continue. And right now, I think a couple of 3 years ago, I met Dr. Campbell. We had some discussions about rinse and chill. And we're back again here in Oklahoma City at the 77th RMC. And I think I had a lot of questions from small, mid-sized, mid-processors about how can they, if you can say, have a more efficient chilling. So this can definitely be an alternative route.
This can definitely improve chilling. We call it rinse and chill, and it's a process that uses vascular rinsing with a chilled solution that circulates through the entire circulatory system and removes a lot of the extra blood. And because this material is running through at the time of slaughter, it also modifies the pH, and we can adjust by adjusting the temperature and doing a couple of other things, we can actually focus in on an optimum pH as well in the animal. And of course, we remove the blood and we chill the animal faster. And our process works basically by stimulating the muscles. One of the things that's in the rinse solution is sugar. So it gives the muscles some metabolic energy that it can use, which it then uses to modify the pH. So some of the advantages include, aside from just better chilling, include a reduction in dark cutting beef, which is probably our biggest customer right now in the United States, is cow killers. And of course, cows have a higher level of dark cutting because they're generally at the end of their life, useful life for dairy purposes and things like that when they bring them in, and so they're not necessarily in the best of shape metabolically. They don't have a lot of sugar reserves. And so the cow plants that we operate in have seen a significant reduction in the number of dark cutters.
Especially in the summer. It's too hot out there, and I think the proportion of dark cutters, they go up.
Yep, you see that in the summer, or also when you get big temperature swings where the days get very warm and the nights get quite cold. So you see them spike in the fall and in the spring because the seasons are changing, and in the northern part of the country, it's just a stress on the animal in terms of the shipping and so forth. And if they're older animals that have already been in pretty poor condition, then you end up with a lack of glycogen left in the muscle, and by running our process, you can improve that.
Can you walk us through, I think one more time, for the some of the folks, especially the folks as small meat processors that may want to understand more about what it is, how does chilling help in the muscle to meat conversion, and I think we can, I guess, step back and because I want them to understand the whole concept.
Okay. Well, basically, by stimulating the muscle, essentially what we're doing in a way is a chemical version of electrical stimulation. Some of the same things happen. The muscle goes into rigor faster, but because we're adding sugar, we're preventing dark cutting, and because we can modify the pH depending on the issue, we don't see the beef version of PSE either.
And can you tell us about some ranges about pH, like what you've seen?
Well, again, it's a matter of pH varies over time. When the animal is first killed, the pH is near neutral, or about 7.
Yep.
And in a typical slaughter process, over the next 8 to 12 hours, the pH will drop down to between 5.5, 5.8 if we're talking beef. Cows typically may be a little bit higher. in the 5.8 range, just because they don't carry as much glycogen unless they've been fed recently, consistently, which is why some people talk about feeding cows in a feedlot before you bring them to slaughter, because you get better yields. Because, of course, a cow, most of its energy has been used in converting to milk. And so there's, if you feed a cow up, there's been some pretty good studies that show that you can get better, you can make it pay for itself if you feed a cow between 28 and 56 days after it's been determined that you're going to send it to a slaughterhouse, particularly beef cows. If you condition them up, you can get considerably better yields.
How about the time of chilling? How does that impact the time of chilling?
Well, the biggest thing about the time of chilling is rinse and chill works better in a place that has good chilling already, simply because it'll get down to temperature faster by using the rinse and chill system. We've estimated that we remove an additional 5% of the heat in the carcass based on the temperature of the water going in. Then, because we essentially quench the metabolism, because instead of having a long time metabolism, we cause muscle contractions when the fluid is applied, and that uses up the metabolic energy. So that energy is no longer occurring as the carcass chills, so that you see a much improved, as much as 5 to 10 degrees Fahrenheit or 3 to 5 degrees centigrade at 24 hours. The deep round will be that much colder because you don't have the carcass releasing metabolic energy. And that's a little bit difficult to explain, but I want to explain the difference between metabolic heat and the heat that just the animal contains. The animal comes in at 100 degrees Fahrenheit, and you've got to take that heat out, get it down to 40 degrees before you can cut it up and safely ship it, because that's the temperature, the safety temperature. But about half the heat in a beef animal that's, shall we say, a normal slaughter beef animal, is what I call metabolic heat, in that it's glycogen in the muscle that has to be that gets turned into lactic acid, which is an important process in the quality of the meat. But then, because that glycogen is getting turned into lactic acid, you're generating heat, and since you've removed the cooling system, if you will, by removing all the blood, that heat stays in the muscle and has to be extracted through the air chilling process, which is very inefficient in terms of how things chill. If you have contact cooling on the meat, it'll chill much faster, but by removing that metabolic heat, you don't have to remove it with your cooler and refrigerator. You don't have, it's been removed already by the rinse and chill process, so the carcass then chills naturally more quickly than it would if it hadn't had the rinse and chill process. And so what that does for processors, particularly most of our customers right now are customers making beef for manufacturing purposes, ground beef and the like. It's really important to them to get their beef chilled so that they can get it deboned and sent out to their customers, and know that those combos of meat are below the 40 degree limit that their customers demand. And so we get there 4 or 5 hours sooner.
Yeah, I was about to ask you that. Compared to traditional chilling process, as far as time goes, you tell us a little bit. I mean, what you said, 4 or 5 hours.
Again, every cooler and every beef plant
absolutely.
is different. But if you have a good chilling meat plant, something with adequate chilling, you're not putting the carcasses too close. All of these things can change how quickly the carcass will chill. But if you have good cooling, and you can get the animal out of that cooler 4 or 5 hours sooner, and into a process, that means that you've got cooler space again to bring the next day's animals in, and things like that. And if you were doing this on fed animals, you have less chance of things like bone sour and other cooling issues that would occur.
So could that be done in less than 24 hours, or in most
You,
cases?
if you have good chilling, yes, we can actually, the last time I did a test in a plant that had really adequate chilling, we were down to 40 and 18 hours, and it took them, their normal process took them about 25 hours to get there. So
So after 25 hours, they were either below 40, and they could start deboning.
right, they could either start deboning or be confident that that meat was going to be, they didn't have to worry about sorting meat out, trying to chill stuff after they deboned it, things like that.
Interesting.
But, that is also good for that extra chilling and so forth, is also good for color, because the myoglobin proteins that are the color pigments degrade faster at higher temperatures. So, yeah, I don't know if you've ever looked at a top round or an inside round. There's always a corner of it that has
There's a gradient, a
color gradient across it, and that corner is down at where the femur bone is, and because the myoglobin spent more time at a higher temperature, it got degraded, and that's why those top round steaks often have a corner that looks a little pale.
Tell us about tenderness. I think I wanted to ask you right out of the bat about tenderness. How does this technology?
We've seen a significant improvement in animals like beef cows that are older animals, as much as a 30 or 40% reduction in shear force of in the longissimus and the muscles that you might be able to merchandise as lesser quality steaks. In fed animals, the difference is smaller because those animals are tender to begin with, and our studies have had some differences in tenderness. Some have shown a significant improvement in tenderness, and some haven't. But that's because with young animals, you have you're already very tender, and so finding a significant, again, from a scientific standpoint, improvement in tenderness is more difficult in those animals. So sometimes we see an improvement in tenderness, sometimes we don't. But again, it depends on how tender the animal is, typically to begin with. And I don't really have a good explanation for why we get a tenderness improvement, except we think because we're adding some metabolics to the muscle at the end. We think that, and we're looking to do some of that research, but we think what happens is by adding ATP via the energy that you get from the sugar and the solution, what happens is in the contraction of muscle, it's actually when you need the ATP to disconnect the actin from the myosin, which is the main protein that's going to cause the tenderness. It's at the beginning of the contraction that the head is released, not at the end of the contraction. And so by allowing those muscles to lose some of those actin-myosin crosslinks, we theorize that that's what makes it more tender, and that's also why it shows up more in older animals than it does in younger animals. Because if you don't have those crosslinks, those actin-myosin strands are smaller in terms of length, and they don't create that. Essentially, the muscle locks up and becomes, when it's in rigor mortis, it's in a cramped state. And you know how if you get a cramp, the muscle is very tight. So by reducing the number of crosslinks present, that's our theory on the mechanism that we improve tenderness.
Interesting. Yeah, it's a good theory. I think I mean, there's a lot of grad students around, and a lot of people that will be very interested and getting to know more about this technology and how it really has a positive
Right.
effect on shear force, like you mentioned.
So we know that happens, and just to looking ahead, we have a delivery system that gets throughout the entire animal. So one of our most recent experiments, we look back at some older research, particularly research that was done with pre-rigor meat back in the late 80s, early 90s. And there was a lot of talk about adding calcium chloride to pre-rigor meat to affect tenderness.
Through the vascular?
No, not so much through the vascular system as they take pre-rigor meat out of the animal and immediately inject it with calcium chloride. And that really wasn't practical. So we looked back at some of that research and said, well, we have a delivery system. So we went and we just completed some tests on lambs, and they actually have a couple of posters on that test here at the RMC. And we showed about a 30% reduction in shear force on tender lambs. I mean, they were lambs, so they were already inherently tender. And we showed a significant 30% reduction in shear force on some muscles. And because the process gets through all of the muscles, numbers weren't enough to be significant in the hind quarter, but
And that's on pre-rigor. That's before they get into the
into
chiller, right?
the chiller, because the process, rinse and chill process, always gets done right at the point of exsanguination.
Yep.
So the animal gets stunned, and then we start the rinse and chill process, because we don't want the vascular system opened up while we're trying to rinse the animal. So we cut the jugulars, we insert a pump into the artery, and then we circulate it throughout the animal, and then we make the final cut, and all the blood gets released
With the solution.
with the solution. And so it really does improve how the animals look from the standpoint of you don't get blood clots. The carcass is much whiter because there's not that blood over the surface. We improve yields because hide pulling is much easier, because so you don't get chunks pulled out of the animal during the hide pull phase, because there's a capillary system between the hide and the actual material in the animal, meat or fat in the animal on the surface, and it makes it a lot easier to pull the hides. And finally, because the meat is more tender and less tightly contracted as it's attached to the bones, we've never been able to do a big enough study to actually show this, but our customers say that they get better yields, boning yields, and there's less meat left on the bones after the process. And again, I think it's because of that actin-myosin bond being partially released. It doesn't happen to every fiber, but it happens to a lot of them.
I have a couple of questions, and how many head a day is your limit to process this? And that's a good question for the folks that want to perhaps apply this or
Right. The fastest plant we have right now runs about 125 head an hour. So
that's a lot.
So we think it's just a matter of engineering
So
to get up to the fastest plants. I mean, the engineers in our group have always managed to come up with a solution. And so we've been working on that, and we know that we can probably do 170 head an hour with no problem at all. And if you're at 170, you only need to double that to be going as pretty much as fast as the fastest beef plants in the country. We think that's simply an engineering problem.
So you can go up to 5 an hour all the way to 120 head an hour. Basically, if you want to do 1 an hour, that's fine, right?
Right.
But that's a limitation,
Well,
and it's good. I mean, I was actually expecting a different answer. I was expecting, since it's complicated, you can only do 12 an hour. But that really surprised me that you can go up there.
The biggest thing is you've got to have the room. I mean, like any bleeding line, this process takes a few minutes in cows, beef.
How long?
4 to 5 minutes on the heaviest ones. Now we're talking 2,500 pound animals. Takes about 2 to 3 minutes on typical slaughter weight animals.
So you need to modify your bleeding station for sure.
Yeah, you need to have enough. And in some plants, there's enough room already there. It doesn't need to be modified. Some of the plants we've had to modify them.
So that means you got to have multiple pumps?
No, we have one
one.
set of one set of pumps and multiple hoses. It's all driven off, and I'm not an engineer, so I don't know exactly how all of that works, but they've developed systems where we have multiple hoses. It's all computer controlled. We get the weight of the animal. The system then pumps precisely the amount of fluid we need, and typically our plants run between 8 and 10%. And the USDA testing that got the process approved as a processing aid was at 10%. So we generally don't recommend anybody run more than a higher rinse percentage than 10%.
So 10% based on the weight of the animal?
Based on the live weight of the animal. And so, again, bigger animals, we're putting the fluid in at a specific pace, so a bigger animal will take more time.
And you need to have, I assume, a tank to keep.
Right.
Because I would assume it's.
The systems that we've built so far come in a container, so it's easy to install. We have everything we need to in the container. We can keep it sanitary, and typically we've found that in order to make it pay, because the system is not cheap, it's all stainless steel, so in order to make that pay for the processor and for us, you've got to be somebody doing at least 100 head or so of beef a day. But if you do that many head, the payback is, I won't get into specifics, but typically 6 to 9 months.
That's awesome. That's awesome. And how many operators do you need?
1 or 2, depending on how fast you're going. Right now, like I said, up to 120 head an hour. You might need a couple more if you're going faster, but then, any of the plants that are going faster have multiple kill stations as it is. So
good. This is awesome. I think this was one of the things, and I'd like to come by your posters and look at, because you mentioned you can do beef and lamb,
right?
So that's also something to
and we've done that both successfully, both in this country and in Australia. So about half our plants in Australia are beef and the other half are lamb. And we have 1 lamb plant here in North America, and the rest of our plants are all beef. So,
excellent. Learned a lot today. And one of the things, you also a K-Stater, right?
Yes, I've had a little bit of a checkered career. I started out in the industry. I got a master's degree, and I worked for a restaurant chain for a while that manufactured its own meat for the restaurant trade. And then after that, I went to work for, at the time, IVP for about 6 years, and did a variety of things for them, including run their laboratories for a couple of years. So after running their laboratories for a couple of years and traveling 40 weeks a year, I decided that I could actually use more education, so that's when I went back to K-State.
Dr. Hunt.
And worked with Dr. Hunt and Dr. Kastner. So I got a PhD and worked full-time for the university for 9 years. And then I went back into the industry and helped open a pork plant in Missouri, Triumph Foods. I also worked for a canning plant for a while, so I've canned meat. Then I went to another company that killed turkeys for a while, and West Liberty Foods is the name of them. So I've basically worked with all of the species in a variety of different capacities, and so now I'm doing rinse and chill, which is everything I learned up to this point has just helped me to make this rinse and chill go better, and understand how much, if people would be willing to try it, how much of a help it would be to the operation.
A benefit.
Yeah.
Well, thank you, Dr. Campbell, for your time. This was a lot of information, but I'm sure that we'll have a lot of questions. Do you want to share your email so that somebody want to contact you? What's the best way?
That would probably be the best way, and it's Bob, B-O-B, at MPSCINC.com.
Okay.
So
We'll
simple.
It's very simple. Thank you again for your time, and
Thanks for having me on your podcast. I've enjoyed it.
thank you.